All right, in this video, we're actually going to go backwards and we're going to generate or find the equation of a conic section with certain given information. And so what we're going to have on something like this is your problem. Uh-oh, let's see, there we go. Um, your problem's going to look something like this. You have to find the equation of the conic section, and I tell you that I give you some information. In this case, you know that the focus is at the point 2, 3, and you have a directrix at y equals 1. I'm not going to tell you what the conic section is. You have to decide if it's a parabola, ellipse, hyperbola, or a circle. Um, this one, since I mentioned the directrix, that's a giveaway that this is a parabola. Um, so this one's going to be a parabola. Now, those of you, if there's any random people out there in the world that are watching this, yes, I'm aware that ellipses and hyperbolas also have directrices, but in my class we didn't talk about that. The directrix for the parabola is the only one we talked about. So if you are my student, then directrix means parabola. So what I'm going to do when I'm working this problem out is I'm going to sketch this information and see what I can figure out. I do know this is a parabola. I have a focus at the ordered pair 2, 3, so let me draw a y-axis, an x-axis, and then I'm going to mark off 2, 3. So let's see, 1, 2, 1, 2, 3, and I will plot a point. That is the focus of my parabola. I also know the directrix is at y equals 1, so I'm going to draw in the directrix right here through y equals 1. Now, the vertex of a parabola, if you remember from a long time ago when we talked about parabolas for the first time, the vertex is right in the middle of the focus and the directrix. Well, if my focus is at a y-coordinate of 3, and my directrix is at a y-coordinate of 1, then my vertex has to be at the point 2, 2. It's going to be right in the middle of the focus and the directrix. Also, I know that my conic section always wraps around the focus. So I know this is a parabola that's going to open up. It's going to hit my vertex and wrap around the focus, something like that. Since it's a parabola that opens up, then I know that my general form of my parabola is going to be x minus h squared equals 4p times y minus k. If it opened left or right, then I would square the y's and not the x's. So I know it's this general form. All I have left to do now is I need to find h, k, and p. If I can find h, k, and p, then I will plug them in, and that will give me the final equation. Now, h and k are always easy. They're probably the easier ones because h and k are the coordinates of my vertex. So I can go ahead and say I know it's at least x minus 2 squared equals, still not sure what p is, 4p times y minus 2. And now I need to find p, and I remember that p is the distance between your vertex and the directrix, or between the vertex and the focus, and that distance is 1. Well, since that distance is 1, I know that p is equal to 1, and I'll just plug in 1 for p. So my final equation is x minus 2 squared equals 4 times 1, y minus 2, or if you're really smart, you can say x minus 2 squared equals, and 4 times 1 is indeed 4, right, y minus 2. And there is our final equation for this parabola. I think will find that working backwards and coming up with the equations is easier than if I gave you the equation you had to work through and find everything else. I found HKP and I plugged it into my general formula. Let's try another one. Let's see, we have vertices at 2, 1 and 2, negative 3, and a focus at 2, 3. Since I have 2 vertices, I know this cannot be a parabola. So it's either an ellipse or a hyperbola. And the way I'm going to figure that out is I'm going to sketch this information. See, 2, 1, 2, negative 3, and 2, 3. So let's look at this for a second. So let me see. Uh-oh. Let's undo that. I'll have a y-axis. Everything's happening at an x-coordinate of 2, so I really don't care what's happening to the left of my y-axis. So I have 2, 1, 1, 2, up 1, that is a vertex. So I'll draw a point, and I'm going to call that a vertex. And then to -3, 1, 2, 3, that is another vertex. And then I have a focus at the point 2, 3. This is a focus. All right, so let's see, if those two are vertices and this is a focus, what I know, let's see, my x coordinates too. Let me go ahead and label this in. All right, there we go. What I know is that we must go through the vertex and we always wrap around the focus. Well, the only way that's going to happen is if I come down, hit the vertex, and wrap around the focus. But if I hit this other vertex, this thing's going to have to be a hyperbola. If it were an ellipse, my focus would be between the vertices. So since my focus is outside the two vertices, I know this is a hyperbola. And since my hyperbola opens up and down, I know the general form is y minus k squared over a squared minus x minus h squared over b squared. I know the y has to be first because this thing is going up and down. If my hyperbola went left and right, then I would know that x goes first. So now what I have to do to finish solving this is I need to find h, k, a, and b. If I can find those three things, or four things, then I can plug them into the equation and I'll be done. HK to me is always the easiest. If you have a hyperbola, the center is going to be right in the middle of the vertices. Since I have both vertices, I know my center is going to be there. All right, so let's see. If I go from -3 to 1, that whole distance is 4, right? Right? And then my center would be 2 units in the middle. So my center is right there at the ordered pair 2, -1. Well, if that's my center, then that is HK. So I'll plug that in for H and K. My equation is y minus k, which is -1, so it's going to be y plus 1 squared over, I still don't know what my a is, minus x minus h, I know that h is 2, squared, I still haven't found my b, equals 1. Now I need to find a and b. Well, I remember that with an ellipse, or I'm sorry, with a hyperbola, a is the distance from the center to the vertex. So this distance is 2. This distance is 2. Since that's 2, I know that a is equal to 2. So I know a is equal to 2. So I can go ahead and plug in 2. So a is going to be 2, so 2 squared, which would end up giving me 4. And then b, I can't get b immediately because b is actually the distance left and right. It's that other distance across that magic box. But I do have a focus, and I know that the focus is always, the distance from center to focus is always c. So the distance from my center to focus, in this case it's 4, that's my value of c. So I know that a equals 2, c equals 4. And in a hyperbola, I know that a squared plus b squared equals c squared, and I can plug in a and c to solve for my b. So a is 2, 2 squared, plus, I don't know what b is, equals c squared, and we'll solve the equation. 4 plus b squared equals 16. I'll subtract 4, b squared equals 12. And I'm going to stop. I'm not going to take the square root because if you look at the equation, my equation actually calls for b squared, and I have b squared. I've already solved for a. I know that a is 2, so when I plug in my a, I end up with y plus 1 squared over 2 squared, and 2 squared is 4, minus x minus, geez, I forgot to plug in my h. What was h? H is 2, so that'd be x minus 2. So x minus 2 squared over b squared, and I know that b squared is equal to 12, equals 1. There's the equation of this hyperbola. Good, good? Good, good? So I sketch the information, and from there, I find my center, which is hk, and then I can use ab or a and c to find b and all that good stuff. Let's try this one. We have foci at negative 5, 4, 1, 4, and a vertex at 3, 4. Again, there's more than one focus, which means we do not have a parabola. And figure out what this is, I'm going to graph this just like everything else. All of my information is happening at a y-coordinate of 4, so I'm going to leave a lot of room above my x-axis because everything's up at 4. So let's go up 1, 2, 3, 4. And I have a focus, one of them at 1, 4. So I have 1 and 4, that's a focus. I have another focus at negative 5, so negative 1, 2, 3, 4, negative 5, 4. There's another focus. And then I have a vertex at 3, 4. So I need to go over 1, 2 more. And at 3, 4, I have a vertex. Okay, well, I look at the orientation of those things, and I know that my graph, my shape, always wraps around the focus. So if I hit this vertex and I go around the focus, I'm actually going to end up going around both of my foci, which is going to create an ellipse. Now, that's a very rough graph, but I don't need a great graph. I just need enough to be able to figure out what the conic section is, and also can tell that this thing is going left and right. So this is an ellipse, and since my ellipse goes left and right, that means my bigger number is going to be under the x term. So it would be x minus h squared, and my larger number, a, is going to go under the x. Y minus k squared is going to be over my b squared, and that would equal 1. So just like usual, I'm going to find the center first. My foci go from negative 5 to 1, which is a total distance of 6, which means my center is going to be 3 away. So if I go from negative 5, 1, 2, 3, that's going to put me at negative 2, and that's my center. My center is negative 2, 4. Okay, well, there's my h and k. I know that h is equal to negative 2. I know that k is equal to 4, and I will immediately plug that into my equation. X minus negative 2 would be x plus 2 squared. Still haven't found my a. Plus y minus k, so that'd be y minus 4 squared over b squared is equal to 1. Now my challenge is finding my a and my b. Well, from my center, negative 2, from that center all the way to my vertex at 3, that is a distance of 5. Well, that 5 went left and right, which means it's going to go under the x. That means 5 is going to end up being my a. The distance from center to vertex is a distance of 5, so I put the 5 under my x, which will actually be 5 squared. Then to solve for b, that's going to be a little bit trickier because b is the dimension up and down. It's under the y, so I need to know how far up and down I go, but I don't have that on this graph. What I'm going to have to do is kind of like what I did with that hyperbola just a second ago. I know that the distance from my center to focus is c. Well, center to focus, that's my c, and that's a distance of 3. Well, I have c, I have a. In an ellipse, I know that a squared minus b squared equals c squared, and then I can plug that in. 5 squared, I don't know b squared, equals c squared, which is 3. 25 minus b squared equals 9. I'll subtract 25. You get negative b squared equals negative 16, which means b squared is going to equal positive 16. And I'll actually stop right there because, just like the last problem, my equation actually asks for b squared, and I have b squared here. If you wanted to go one step further and actually take the square root and say b equals 4, you could, but when you plug in b equals 4, you're just going to end up squaring it anyway and going back to 16. So now that I have a and b, I'm going to plug those in. My final equation is going to be x plus 2 squared over a, which is 25, or a is 5. 5 squared is 25, plus y minus 4 all squared over b squared, which is 16, equals 1. There's our equation. You good? Good, 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 good. All right, I have one more, and then we'll call it quits. And this one, because give you an asymptote. This one I'm actually going to pull out some. I'm going to pull out some graph paper, and you will have graph paper available when you take this test. So um, I don't know. Let's see. So there's my. Geez, why does it do that? Why did I draw that line? I don't know. Okay. Um, I'm going to start by graphing this information. I have a vertex at 3, 1. I only gave you one vertex, but then I mentioned an asymptote. The only graph we have that involves asymptotes is a hyperbola. So since I see that this problem has an asymptote, I know that this is a hyperbola. I have a vertex at 3, 1, so let me get my x and y axes in here. I need to leave room to go right 3 and up 1. So I'll move my y-axis to the left a little bit. So I'll go right 3, up 1. Here's a vertex. Yeah. And then my asymptote is y minus 1 equals 3 halves x minus 1. That is in point slope form. And my point, this is point slope form, which I prefer point slope form. The point is 1, 1. Remember, the equation is y minus y coordinate equals x. Slope x minus x coordinate. So my point is 1, 1, and the slope is 3 halves. So what I'm going to do is I'm going to graph that asymptote. I have a point at 1, 1. It goes through that point, and then my slope is 3 halves. So I'll go up 3 and over 2. I can also go down 3 and left 2, and that is what this asymptote is going to look like. So here's the asymptote. That's my vertex, and since my vertex is on the right side of that asymptote, what I know is that this thing's going to open left and right. Also, this point, if you remember when we were doing the asymptotes, the point is also the center of the hyperbola. So I actually have, with that point, I've given you h and k. H equals 1, k is equal to 1. So here's the center. And since my vertex is on the right side of my center, I know that this thing is going to open left and right. So it's going to be a hyperbola that does something like that. I'll have another vertex on the opposite side of the center, and this is what my hyperbola is going to look like. It's a hyperbola going left and right, which means x is going to be first. So x minus h squared over a squared minus y minus k squared over b squared is equal to 1, and we've already found h and k. So that's x minus 1 squared over a squared minus y minus k squared over b squared equals 1. Wait, I know what k is. K is 1, so that's going to be y minus 1 squared over b squared. Now we have to find our a and our b. A is not going to be very hard because A in a hyperbola is always the distance from center to vertex. And I can look and see that that distance is 2. So I know that A is equal to 2. So what I'll do, I'll go ahead and just take out my A squared and I'll plug in 2. 2 squared is 4. Now to find B is a little bit different. Now this one is actually going to be easier than the last one because I gave you the slope of my asymptote. And if you remember, the slope of my asymptote is determined by the corner of that little magic box. So I know that this point right here is the corner of our box that we use to graph our hyperbola. And I can tell that I went up 3 to get to the top of that box and right 2. Well, up 3, that's going to be our B. That's a distance of 3, so I know that B is equal to 3. And so I'll take out my B squared. 3 squared is 9, and there we have the equation. So by giving you the slope of my asymptote, I actually gave you the A and the B for this conic section. Yeah, so there we go. That is working backwards to find the equation of a conic section. Y'all's wax paper folding project is based on this type of information, so hopefully this will help you when you work on that.